Good day, sir. So, we are the group 3 and we will be discussing direct current circuit in this lesson. I am Jabemelia F. Cabarubias.
I'm Carl Janiel Peralta.
I'm Caster Aaron M. Corpus.
I'm Chinesa Tibuso.
I'm Chester Maghanoy.
I'm Giliana Arcelo.
I'm Cartagena Machi David.
I'm Neil Pakinggan.
I'm Pamela Sara.
I'm Rose Golpeo.
So, here is the most important learning competencies. Number 1 is to evaluate the equivalent resistance, current, and voltage in a given network of resistors connected in series or parallel. The second one is calculate the current and voltage through and across circuit elements using Kirchhoff's loop and junction rules, at most 2 loops only. And lastly, solve problems involving the calculation of currents and potential difference in circuits consisting of batteries, resistors, and capacitors.
So electric circuit. Electric circuit is composed of individual electronic components such as resistors, transistors, capacitors, and inductors connected by conductive wires or traces where electric current can flow. An electric circuit includes a device that gives energy charged particles constituting the current, such as a battery or a generator, devices that use currents such as lamps or computers. So the definition states that the electric circuit, in order to work, kailangan merong components such as resistors. Resistors from the word itself, resist, meaning pigilan. Ibig sabihin po nito, pinipigilan ng resistors ang pagkalat ng electric current into different mediums and stabilizes the flow of a current. And then the transistors, it is a device that regulates current or voltage flow and acts as a switch or gate for electronic signals. And then the capacitor, it is a device used to store an electric charge consisting of one or more pairs of conductors separated by an insulator. And lastly, the inductors is a component in an electric or electronic circuit which possesses an inductance. So the stored charges from all these components will supply the needed energy to cause motion or kinetic activities. Cell or batteries. Cell is a single unit device which converts chemical energy into electric energy. A battery usually consists of a group of cells and both of them are a power source. So, of course, we all know that the battery supplies energy to a certain object in order for it to work. Ang battery po ay isang medium na nagko-convert ng chemical energy into electric energy since it is made from certain elements that causes electric whenever it is mixed together and triggered by a certain conductor from a source. And then the load, any device attached to an electrical circuit that is activated or energized by the flow of electricity to it provides the electrical loads on the circuit. Lights, TVs, heaters, and appliances are load devices that consumes power. Ang load naman po is a device na nag-activate ng flow of an electric energy whenever it is tapped into a certain electrical power source, like sockets, for example. Then the conductors or wires, a material that are made of copper wires that allows electrical current to pass easily through. One end of the wire is connected the load to the power source and the other end of the wire connects the power source back to the load. So the conductors are the link between a device and an electronic energy source. Kagaya po ng mga charger natin which have wires. Dito po dumadalo yung electric charge mula dun sa source papunta sa device na paggagamitan natin. And switch is a control consisting of a mechanical or an electronic device for making, breaking, or changing the connections in a circuit. So, and for the switch, it simply means that a switch is the eternal control of the human regarding the flow of electric current inside its components, either to stop or redirect its flow. Next is the electric circuit symbols. The first one are the two symbols of switch, the open switch and the closed switch. Then the next one is the fuse, in which it breaks the circuit if a fault in an appliance causes too much current to flow. And then the next one is the battery. The symbol for a battery is made by joining two or more symbols for a cell together. And then the cell, as you can see has a longer and a shorter line, which means that the longer line represents a positive terminal and the shorter one represents a negative terminal. Note that in physics, each of these is actually called a cell, but only when you have two or more of these cells connected together is called a battery. And then the voltmeter, which is a letter V enclosed in a circle. A voltmeter measures the voltage of a direct or alternating electric current on a scale. And then the other one is the ammeter. The same with the voltmeter. Ammeter symbol is a letter A enclosed in a circle. An ammeter is used to measure current. Next is the lamp or bulb. It is shown that as an X enclosed in a circle or an intersected half curve inside a circle. And the last one is the resistor, a rectangle placed on a plane or a zigzag bit-like indicator. Resistors are one form of passive components and one of the most used within electronic equipment. So under the electric circuit symbol is the example of a simple electric circuit in which it is composed of a battery, a switch, a wire, and a light bulb.
Okay, for the series and parallel circuits, the components of a circuit may be connected in a series, parallel, or a combination of series and parallel. A series circuit is a circuit that contains more than one electrical component connected one after the other in a single path. In series circuit, the current flows in a single path and is the same in all parts of the circuit. If the circuit is broken at any point, no current will flow. Christmas tree lights are normally connected in a series. So in layman's terms, series is a circuit that pertains to the current flow that goes through one path. On the other hand, a parallel circuit goes through multiple paths for the current flow. So yung series circuit, it's not usually used in housing electricities kasi kapag nasira yung isang ilaw mo, hindi nagagana lahat. So mas preferred ang parallel circuit. Then, let's say the signs of a resistor, which is yung zigzag lines dyan in the figure below, on the slide. Let's say it is a light bulb. So, kapag series circuit ang gamit, yung light bulbs, pwede siyang maging medyo madilim or more dimmer. But when it comes to parallel circuit, the light bulbs may seem more brighter. Why? Because we have this thing called voltage drop for each resistors. Yeah, voltage drops for each resistors. Meaning to say, yung current flow ng electric grid. Moving on, kapag i-calculate natin yung current flow in a circuit, we will be using the Ohm's law. So to get the total resistance of the series circuit, we have to add every resistors. Like that in the figure, 3 plus 10 plus 15 is equals to 18. So that will be the total resistance. So to find the current flow of the circuit, we have to use the Ohm's law, which is the voltage is equals to current and resistor. Then after getting the formula, we have to substitute all the values. Then kapag nakuha natin yung voltage, which is 9, then yung resistor, which is 18, we will have an ampere of 9 amperes, which travels through the whole circuit series. Then we have this thing called voltage drop, which is sinabi ko kanina, which pertains to the decreased value of the ampere that goes through the circuit. For example, Deb, pakibalik sa kabilang slide. Sige, okay na yan. So, for example, dyan sa 3, mababawasan siya each and every time na dumadaan siya sa resistors. So, magkakaroon kayo ng voltage drops. So, do take note that all voltage drops is always, the summation of all voltage drops is always equivalent to the voltages that is generated by the battery. Okay, next. So it's not really the same with series. It's not really the same with parallel circuit kasi when you add resistor to a parallel circuit, the total resistance decreases. However, the current being drawn from the battery will increase. Okay, done.
Resistor is an electrical element component that resists or limits the flow of a current. We calculate the resistance using Ohm's law, a law stating that electric current is proportional to voltage and inversely proportional to resistance. It is introduced by George Simon Ohm. The formula for Ohm's law: voltage equals to current multiplies to resistance. Ohm's law in a series circuit. As you can see, there is only one path. The formulas are given for equivalent resistance, total voltage, and total current. For example, find the equivalent resistance, total current, and voltage across each resistors. We are given R1, or the resistance 1 is equals to 6 ohm, R2 6 ohm, and R3 is 4 ohm. The total voltage is 10 volts. To find the equivalent resistance, we just add all the resistance, which will equal to 16 ohm. To find the total current, we just substitute 10 volts divided by 16 ohms would equal to 0.625 amperes. And then third day voltage, we substitute also V1, or for example, V1 is equals to current 1 multiplies to resistance 1. It would be equal to 0.625 amperes multiplied by resistance, which is 6 ohm, with equal to 3.75 volts, and so on. Ohm's law in a parallel circuit. As we can see, there are multiple paths. The formula are given. For example, find the equivalent resistance, total current, and the current across resistors. Given, resistance 1 is equal to 6 ohm, resistance 2 is equal to 6 ohm, and resistance 3 is equals to 4 ohm, and the total voltage is 10 volt. To find the equivalent resistance, we use the 1 divided by equivalent resistance, and we would get 0.58 ohms. Note that this is not yet the equivalent resistance. To get the actual equivalent resistance, we get the reciprocals, which would equal to 1.72 ohm. And next, we get the total current. Substitute is equal to 10 volts divided by 1.72 ohms would equal to 5.81 amperes. Next, we would find the current across each resistors. For example, current 1 is equal to voltage 1 divided by the resistance 1. We substitute 10 volts divided by resistance 1, which is 6 ohms, would equal to 1.7 amperes, and so on.
So in this part of our presentation, we will talk about battery. First, what is a battery? A battery is a combination of cells that may be connected in series or in parallel. The cells are in series when the positive terminal of one cell is connected to the negative terminal of the next cell, and so on. The cells are in parallel when all the positive terminals as well as all the negative terminals are joined together. So kung makikita natin sa illustration, which is yung A, yung in parallel, and B is in series. So yung A, makikita natin yung positive terminal, nakakonect siya sa another positive terminal. Pero kung in series siya, yung positive terminal, nakakonect siya sa negative terminal. And take note that only identical cells must be connected in parallel. If two cells having different electromotive forces are connected parallel to each other, they will try to balance each other. The one with the higher charge discharges into the lesser charge until their voltages are equal. So in the table, we have properties of series and parallel combination of cells. So in the first column, we have the quantity, which is the total electromotive force, or E total, total internal resistance, or R total, and current, which is represented by N. So if the cells is in series and we are looking for the total electromotive force, or E total, the total electromotive force is the sum of all the electromotive forces in each cell. So E total is equal to E sub 1 plus E sub 2 plus so on and so forth. And if the cells is in parallel and we are talking about the total electromotive force, or E total, then E total is equal to E sub 1 equals E sub 2 equals so on and so forth. If the cells is in series and we are looking for the total internal resistance, or R total, then the total internal resistance is the sum of the individual internal resistances of the cells. So R total is equal to R sub 1 plus R sub 2 plus R plus so on and so forth. And if the cells is in parallel and we are looking for the total internal resistance, then the total internal resistance is equal to the internal resistance of one cell divided by the n number of identical cells, or R total is equal to R sub 1 over n. If the cells is in series and we are looking for the current, then the current is the same in each cell, which is L total is equal to L sub 1 equals L sub 1 equals so on and so forth. If the cells in parallel and we are looking for the current, then the total current is the sum of the individual currents passing through each cell. So L total is equal to L sub 1 plus L sub 2 plus so on and so forth. Take note that wiring cells in series with one another within a circuit increases the total voltage applied across the circuit. So kapag in series daw yung pagkakawire ng battery, ibig sabihin, yung total voltage niya, yun yung tumataas. Kapag naman, if the cells is wired in parallel, it does not add their voltages together, but their capacities are added up, and therefore the battery will last longer. So kapag in parallel naman siya naka-wire, hindi tumataas yung voltages niya, pero mas tumatagal yung capacity nung battery.
So I'm gonna be discussing the Kirchhoff's law. It is sometimes difficult to determine the current in a complex network by just computing the equivalent resistance. There are circuits containing several loops, with each loop having its own voltage source and resistance. So Kirchhoff's law quantify how current flows through a circuit and how voltage varies around a loop in a circuit. The law states that the total current flowing into a node or junction in an electrical circuit must be equal to the total current flowing out. It is also known as the junction law. Kirchhoff's voltage law states that the algebraic sum of all the voltage in a given circuit will be equal to 0. So the German physicist Gustav Kirchhoff formulated two laws that make it possible to find the current in each part of a circuit, no matter how complicated the circuit is. Kirchhoff's first law, also called Kirchhoff's junction rule or nodal rule, applies to a junction. So Kirchhoff's law, which allow for the computation of currents, voltage, and resistance in electrical networks were originally published in 1845. He generalized the equation describing current flow to the situation of electrical conductors in 3 dimensions, extending the ideas of German physicist George Simon Ohm. A junction or node is a point in an electric circuit where 3 or more wires are connected. Kirchhoff's junction rule states that the algebraic sum of all current entering and leaving a junction must be equal to 0. It is also known as Kirchhoff's current law, which is a statement of conservation of charge. So the second law is a consequence of the conservation of energy. It is known as Kirchhoff's loop rule or Kirchhoff's voltage law. A loop is defined as closed conducting path. And Kirchhoff's loop rule states that the algebraic sum of the electromotive force and the voltage drops in any loop must be 0. So in a voltage, when applying the rule, it must be equal to 0. So here the following are the steps to follow when applying Kirchhoff's law. Number 1 is to label the current in each branch as I sub 1 and I sub 2 and so on. Number 2 is assume a direct for each current. Number 3 is in writing the junction equation, the current entering a junction is positive whereas the current leaving a junction is negative. And number 4 is in applying the loop rule, begin at the point in the loop and go around the loop in a clockwise or counterclockwise manner. And number 5 is in writing the loop equation, the following sign convection must be observed. Letter A is the electromotive force is positive if it traverses the negative terminal to positive terminal. It is negative if it traverses from the positive terminal to the negative terminal. And letter B is the potential difference across a resistor is negative when the resistor is traversed in the direction of the current, otherwise it is positive. And lastly, the unknown currents are usually determined by solving simultaneous loop equation as well as junction equation. So here is the example. The letter A is the sign convection for EMFS. The travel direction from negative to positive and travel direction from positive to negative. And letter B is sign convection for resistors, travel opposite to current direction and the negative travel and current direction.
Okay, now we're moving on to the RC circuit or the resistor capacitor circuit. An RC circuit is a circuit that contains both a resistor and a capacitor at the same time. It's called an RC circuit. A DC circuit is constant, but in some cases, the capacitor of a DC circuit will produce a current that varies depending on time. The first order of an RC circuit only contains one resistor and one capacitor. So now proceeding to the diagram below, let's pay attention where an RC circuit has a battery, resistor, and a capacitor in series. So as we can see at diagram A, the RC circuit has an open switch. Therefore, the current isn't flowing from the battery to the resistor and the capacitor. And as for the diagram B, the switch is closed. Therefore, the current is flowing from the positive terminal of the battery, going across the switch into the resistor, and then to the negative side of the capacitor, into the capacitor. It will then exit the capacitor and return to the battery. So at first, charging the capacitor. A capacitor is being charged when the line is closed, then the voltage is moving from the battery to the capacitor. The capacitor slowly charges off depending on the time interval of the current. Okay, so now we will be moving on to how to know the percent of the charge while the capacitor is charging. The formula for the charging of the capacitor is voltage of the capacitor is equals to 1 minus Euler's number raised to time over RC. Since the time itself also uses the RC symbol, we can cancel that out. Okay, so I will be making a sample diagram. Here's the battery, here's the switch, the resistor, the capacitor, and back to the battery. Okay, so let's assume that the battery has 10 volts. Currently, the current isn't flowing because the switch is open, but if once the switch is closed, the series will start from the battery to the direction of the resistor, the capacitor, and back. Although this current causes the capacitor to charge. So to get the voltage, the capacitor, so let's see, this is the time constant, the percent of the charge, and the voltage. So let's say that we have 1, 2, 3, and 4 time constants. So 1 minus Euler's number, which is also equivalent to 2.72. There. Remember that Euler's number is equivalent to 2.72, or let's say approximately equal to 2.72. So we raise that with -1 from time, as we can see here. Okay. So all in all, the equation will be 1 minus 2.72 raised to -1. And with that, you will get 0.632 or 63.2% charge. Same goes for the others. 2. You will get 86.4% charge. As for the third time constant, we would get 95% of charge. And for the fourth time constant, you would get 98.1% of charge. Let's see if we can raise to 5 time constants. Okay, so by this point, the capacitor is now fully charged, or 99%. So to get the voltage, we just have to know what is 63.2% of 10. Which is 6.32 volts. And so on, with 86.4% of 10 is 8.64 volts. 95% of 10, we have 9.5 volts. 98.1 percent of 10, you have 9.81 volts. And lastly, with the 99% with 9.93 volts. So there, as you can see, that is how you compute the charging of the capacitor. So in the end, the graph should look like this. Instead of it raised directly up, it would be slightly curved, where at first straight and then slowly being horizontal, this being 10 volts. So that is how you graph the charging of the capacitor, and as well as the formula and solution of getting the voltage. Discharging a capacitor. After a capacitor is fully charged, a discharge will occur. The current is no longer at use. Similar to the charging process of the capacitor, the voltage of the capacitor slowly drops as time passes. Now moving on to the discharge of the capacitor. The voltage of the capacitor this time is equal to Euler's number raised to the time constant. Let me fix that. Okay. So the formula for this one is 2.72 raised to time. Okay. Similar to the first one, but this time here is the battery, the switch, resistor, the capacitor, and back to the battery. So as we all know, when the switch is closed, the battery slowly charges up the capacitor. But this time, after the capacitor is charged and the switch is open, the capacitor will begin to discharge. Okay, so almost similar to the first one. Here's the time constant. Here is the percent of the charge of the capacitor, and here is the voltage. Okay, so this time 2.72 raised to -1. So we get the percentage of the first time constant is 36.7%. As for the 2, 13.5%. For the 3, 4.9%. Sorry, let me tidy that up a bit. 4.9%. As for the 4, 1.8%. And lastly, for the fifth number, we get 0%. It being the voltage from 10, 3.67, no, not percent, 3.67 volts, 1.35 volts, 0.49 volts, 0.18 volts, and lastly 0 volts. And now moving on to the graph. It is still similar to the charging, but only this time the graph shows that the voltage is going down. So as you can see from the equation here, the graph should look like this. Drops down dramatically and then slowly being horizontal. There. Until it reaches 0 volts.
For the activity number 1, 4 resistors, when connected in series, give an equivalent resistance of 75 ohm. 3 of the resistors have values of 18.0 ohm, 6.0 ohm, 24.0 ohm respectively. What is the resistance of the fourth resistor? Una, hanapin daw muna natin yung mga given. Ang given ay R sub 1 is equal to 18.0 ohm, R sub 2 is 6.0 ohm, R sub 3 is 24.0 ohm. Tapos, 75 ohm ang equivalent resistance. Ano daw yung resistance ng pang-apat na resistor? Ang gagawin natin is, i-add lang natin lahat ng given. 18.0 ohm plus 6.0 ohm plus 24.0 ohm is equal to 48, tapos 75.0, our equivalent resistance, minus 48. Kaya ang naging sagot natin is 27.0 ohm.
For problem number 2, if the resistor from sample number 1 are connected in parallel, what is the value of the total resistance? For this question, it is asking for the total resistance of a parallel circuit, which the formula is 1 over total resistance is equals to 1 over resistor 1 plus 1 over R2 plus 1 over R3 plus 1 over R4. To solve for the total resistance of a parallel circuit, we just have to replace the value from the formula. 1 over total resistance is equals to 1 over 18 ohm plus 1 over 6 ohm plus 1 over 24 ohm plus 1 over 27 ohm. To get the value that is in the leaf, you have to find the symbol that is encircled in the slide on your scientific calculator. For example, 1 over total resistance equals to 18, then find the symbol that has x over negative 1, and the answer that you will see is 0.0, then the rest will be 5. You just have to round up the number, like in the leap, the answer will be 0.06, then continue to the next resistor 2. So 1 over total resistance is equals to 0.06 plus 0.17 plus 0.04 plus 0.04. 1 over total resistance is equals to when you add all the resistor, you will get 0.31. Then press the -1 again to erase the 1 over total resistance. Then the final answer will be total resistance is equals to 3.23 ohm. Next slide. For problem number 3, three resistors with values of 60 ohm, 30 ohm, and 20 ohm, respectively, are connected in series to a 110 voltage battery of negligible internal resistance. Draw a circuit diagram and find the equivalent resistance of the combined resistors. Current flowing through each resistor, voltage drop across each resistor, and the power dissipated by each resistor. The question is looking for the circuit diagram, total resistance, current voltage, drop, and power dissipated by each resistor. For the circuit diagram will be represented by the figure shown in the slide. To solve for the current is equals to voltage of the battery divided by the total resistance, which can be seen on the letter B. For solution of the total resistance is the same from the problem that was solved on sample problem 1, where total resistance is equals to resistor 1 plus R2 plus R3, which will give you 60 ohm plus 30 ohm plus 20 ohm is equals to 110 ohm. To calculate the voltage drop across each resistor, we will use the formula of voltage 1 to current 1 times resistor 1, which can be seen on the letter C part. Last is to solve for the power dissipated by each resistor. You can use three formulas, but we will be using the formula that is in the leaf, which is power is equals to voltage times current. So, seen in the letter D is that power 1 is equals to voltage 1 times current 1 is equals to 60 volts plus 1 ampere is equals to 60 watts. Power 2 is equals to voltage 2 times current 2 is equals to 30 volts times 1 ampere is equals to 30 watts. Power 3 is equals to voltage 3 times current 3 is equals to 20 volts times 1 ampere is equals to 20 watts. And that's for the problem number 3.
Now for the circuit simulation, physical electric circuits built with real components can be challenging and complicated. This means that creating your circuit may require parts, and maybe you do not even have parts, but you have unique idea that you think will work. This is where simulators are useful. You can design and build in a virtual environment, adjust and edit virtual component parameters to match real tested components, swap and change parts as needed, or simply just let your imagination do and see what it takes to break it. Uh, uh, there is a software used by engineers, students, and professors. It is called Multisim, and it is a powerful schematic capture and simulation environment that can be used to simulate electronic circuits and prototype printed circuit boards. This image is the example of the Multisim software. Okay, next.
And as for the grounding, notes to take in. Ground wire or any grounding material is usually made up from bare copper since it has a very low resistance. Grounding simply means to drain all of the current into a grounding object. And electricity will only flow in a complete circuit. And electricity always tries to return to its source. Electricity takes all available paths to complete a circuit. Electricity takes a preference to a path with the less resistance and more current will flow in that path. And below, the figure below is a common residential circuit. I say next. And this figure is a common residential circuit in America. The upper wire is a hot wire which travels through a bus bar. Ay, sa kabilang, ano pa pala slide? Kaninang slide? Ayan. The figure below is a common residential circuit in America. There are two wires included in this circuit, which is the hot and neutral wire. The hot wire travels through a bus bar and through a bus bar, and next is through a bulb. After a bulb, it travels through the neutral wire back to its source, which is the transformer. And the grounding here is that if ever the hot wire touches a metal or any other material in a circuit, all the electrons or the electric current will flow through it to the grounding wire. Since it has a very low resistance, electron will take a preference to that path, and it will also come back to its source, which is the transformer. Next. And dito naman, may dalawang ground rod tayo, yung dalawa sa baba na naka-connect. Ayan yung parang ground wire kanina na isa-suck up niya yung mga electric current pag nag-overheat yung ibang material ng circuit. At kunyari, may makukuryente yung circuit, dadaan siya sa ground wire and through the ground rod. At since yung lightning is yung source na ay earth, babalik siya sa earth, which is yung pinaka source niya.